Okay, this is Atomic Theory, Lesson 4, and tonight we're just going to focus on what an isotope is and how do we determine the average atomic mass of a given element given all of its naturally occurring isotopes. Rather short lesson, and we'll get started now. So a formal definition would be atoms of the same element with a different mass number. And what that means is they have the same atomic number, but the mass number is different. To take that one step further and put it in layman's terms, same number of protons different number of neutrons. Because we know that the mass number is made up of the protons and the neutrons. So if the atomic number, which is our protons, is staying the same, then the only thing that could be changing is the neutrons. These are different types of what's called isotopic notation. Isotopic notation. So I can write C-12, and as I told you the other night, these values, the 12, the 13, and the 14, refer to the mass number. Or I can write them like this, where this is my mass number, and I have my atomic number on the bottom. Is there another example there? Oh, there they are. And here's two others, U-238 and U-240. They are isotopes of one another, same atomic number, different mass number. So why does carbon have a mass of 12.011 on the reference table? This is carbon's atomic mass, or average atomic mass, which is the average weighted mass of all naturally occurring isotopes of carbon. There exist 3 different isotopes of carbon in the atmosphere, as shown above. So you have carbon-12, carbon-13, and carbon-14. Well, you might be thinking to yourself, well, if it's just the average, then I add up 12, 13, 14, divide by 3, and I get the average mass. That's not how it works. That would be correct if we were just averaging a set of numbers in math. But in science, these isotopes are present in varying abundances in the atmosphere. So carbon-12 might be 98% abundant, where carbon-13 is maybe 1.1% abundant, and carbon-14 is less than 1% abundant. So we have to take that percent abundance into consideration when calculating average atomic mass. So we take the abundance, which is another word for percent. Percent equals abundance. I'm going to show you 2 different ways to do this. In decimal form, times the mass of isotope 1. Then we do the same thing, percent in decimal form, times mass of isotope 2, for however many isotopes they are, and we add them all up. Now, in order to go from percent to decimal, we have to know one of 2 things. We either have to divide by 100 to get it out of percent, or we have to move the decimal place 2 places to the left. Those are your 2 choices. Or you can do this problem another way, and I'm going to show you both. The second way is to take the percent times the mass and I'm just going to show you 2 plus percent times mass. I've added those up, and then you can divide your answer by 100. So you can, in this second way of solving the problem, you don't have to worry about taking the percent and putting it in decimal form. Just take your percent times your mass plus your percent times your mass and divide by 100. You do the dividing by 100 at the end. So let's try a couple of these. We're going to use carbon 12 and carbon 13. So if I were to move the decimal place 2 points to the left, I'm going to get 0.9889 on this one and 0.0. So this is why it's dangerous to do that, because if you forget the 0 as a placeholder, you're going to mess it up. So I'm going to draw this in half, okay? And the first thing that you're going to do is 0.9889 times the mass of carbon 12, which is 12, plus 0.0111 times the mass of carbon 13, which is 13. And we're going to add those up. I'm going to do that right now. Normally I would just put this in my calculator and do it all in one shot. I'll explain that in a minute. So this one's going to be 11.8668. And the second one is going to be 0.1443. And then we just add them up. And I get 12.0111. 3 ones as my answer. And this is the average mass. Now let's do it the way I showed you the other problem. So now I'm going to leave it in percent, and I'm going to do 98.89 times 12 plus 1.11 times 13 divided by 100. So in my calculator, I'm going to do this all in one shot. I'm going to do parenthesis 98.89 times 12 and a parenthesis plus parenthesis 1.11 times 13 and a parenthesis equals. So I can put that over here if you want to see it. That equals 1201.11. And now I'm just going to divide that by 100. And I get the same answer, 12.011. Let's do one more. Boron. We have 2 isotopes. I have 2 ways that I can do this. 0.199 is out of percent and 0.801. So I can set it up this way. 0.199 times 10.0130 plus 0.801 times 11.0093, and I can add that up. And if you do this correctly, you should get 10.81. Over here, I'm just going to multiply by the percent, 19.99 times 10.0130 plus 80.1 times 11.0093 and divide by 100, and I still get 10.81 as the average atomic mass. And that's how we calculate average atomic mass. We will practice some of those in class tomorrow after a short quiz. Have a great night.